Hello and welcome to Robot 3D Prints. I'm here to do a short tutorial on creating beveled gears in Fusion 360. I did do a live stream about this, which was quite a long one, but I'm here to just give you a quicker rundown on how to do it and hopefully avoid any problems. Now, first thing you want to do is probably pause this video and create these user parameters to work with within Fusion 360. Most important things you probably need to know are that you have to set values for 4 of the parameters. The others all calculate based off those values. So the 4 that you need to set values for are gear teeth 1, gear teeth 2, the module, and pressure angle. Now, pressure angle is generally 20 degrees or 45 degrees, depending on your needs. Will probably depend on the value you use, but for 90% of the stuff that I've used and seen in the past, it's been pressure angle of 20 degrees. And the module is generally a value between 1 and 5. It's done in millimeters. The actual correct module value is calculated by dividing the gear teeth by the pitch, but often you won't know the pitch to begin with, so unless you use a website to pre-calculate those values, you can pretty much just come in here and change the values, which will give you a rough idea of what size your gear will be. So this pitch diameter, or pitch diameter 1 and pitch diameter 2, will be roughly the actual size of your gear. It'll be slightly smaller because the pitch diameter circle sits slightly inside the actual external circumference of the gear itself, but only by a very, very small margin. So as you can see, with the value of a module of 4 and 20 gear teeth and pressure angle, it's given me a pitch diameter of about 80 millimeters, which, depending on your needs, may or may not be right. And it's also given me the same for the second gear, which again, depending on what you need, will depend on what size those are. If you need different size gears, like I did for my mixer, you'll want to change the amount of teeth on one of the gears. So for my mixer, I had 40 teeth on the big gear and 16 teeth, I think, on the pinion, which resulted in one really big gear and a smaller gear, which I then duplicated across the other side. But you can change those values. So if we come in here and we change that to 2 millimeters, you'll see that those values recalculate themselves. So that one halved itself to 40, and the cone rad and back cone rad and so forth changed as well. So yeah, we'll go with 2 millimeters for now. That'll be fine. So now that we've got that out of the way, what we want to do is create a sketch. I'll just do it on the front plane and start by creating a line. It must be a construction line. We'll go from the center point straight down, tick that, and for this line we don't want it to be a construction line, just go roughly through the middle there. Now we want to set the dimensions of this line, and this is going to be pitch diameter 1, pitch dia 1. I just shortened a lot of the stuff so I don't have to continuously type it. And then we want to set another dimension from the outer point back to the center line, bring that down, and that's going to be pitch rad 1, pitch radius 1, so half the diameter. And basically when you create your second gear, rather than doing it vertically first and then horizontal like I've done here, you would actually do your construction line horizontal and then make a vertical and dimension that vertical line as pitch diameter 2, and then from the halfway point to the outer point as pitch radius 2, and basically you repeat all of the steps that I'm going to do showing here, but anywhere where you use a number 1, change it to a number 2. So cone rad 1, back cone rad 1 would be cone rad 2, and back cone rad 2. So with that said, let's get back into creating this, and we'll create a line from this point up to the top point, another one from that point down to the bottom of that point, and then we want to set our dimensions, and this has to be parallel. So if you find your dimension is going that way, you need to make sure that you get so the dimension is parallel with the line itself, otherwise it's totally not going to work. So the dimension for that bottom diagonal line is back cone radius 1, and for the top line is cone radius 1, and then we need to draw another little line just going from that outer point, staying perpendicular so it's just like an extension of the back cone rad line, and then we want to create a point on the opposite side, and these 2 points, this outer point is called the addendum and this inner point is called the dedendum, and using that we're going to dimension these. So you go from the dedendum down to the base, and again make sure it's parallel, and we want it to be back cone rad 1 minus dedendum, and from the addendum point down there, and again make sure it's parallel. For this one we want back cone rad 1 plus addendum. Alright, so now that we've got those points dimensioned and placed, use our line tool again and create a line from the addendum point up to the origin, and same from the addendum point to the origin, and then we'll create a line. You don't have to be specific or pedantic with this, you can kind of play around with the shapes, but you want a line that cuts from that line the two lines you just created, and then bring it across to the center line, and then bring it down, and across. And the most important thing is, with this baseline, you just have to make sure that it connects somewhere on this back cone radius line below that addendum point. As long as you do that, you should be a-okay. So with that done, that's going to be the profile of our gear. So we select all of the parts of this. And we go create revolve. So we've got our profile selected. We'll just select the center line as the axis. Okay. And there's the body for our beveled gear. So for the next part, we just want to unhide that sketch that we did. And we want to go to construct plane tangent to face at point. And the face we want to use is this lower face, and the point that we want to use is the addendum point. So click OK on that, select our sketch plane, create sketch, and I'll just rotate it slightly so we can see the base point, because what we want to do is project that base point so we can use it as the center point for our next part. And just to realign my sketch, I'm going to stop that and double click there. So just to tidy things up, hide that body, and now we want to use our circle tool and create 3 circles using that projected point as the center. So circle 1, circle 2, circle 3. Now we need to dimension those 3 circles. So D for dimension, and we want it to be back cone rad 1 multiplied by 2. Make sure that's multiplied. And the reason we're multiplying it by 2 is because it's a diametrical dimension, whereas we're actually using back cone rad, which is the radius. So we just multiply that by 2. And then we set another dimension from that center circle to the outer circle. And that one is equal to addendum. And one more dimension from the inner circle to the center circle, and that one is the addendum. Alright, so now that we've got those, what we want to do is create a construction line. This is just to make things a little bit easier. From the center up to about there on the addendum, and then stop construction line, and if we click on that point and hold the left mouse button down, you can create an arc outside of the circle, which, as you can see, it automatically makes tangent with that construction line. And then we need to create another construction line. Crosses through those 3 circles. And then what we want to do is create a point that is at the point where that arc coincides with the center circle. So we go point, place that there. Now I want to use that point, select the point and that construction line and make them coincident, and then select the construction line and the arc and make them tangent. Alright, so now we need to draw one more, well, actually I'll draw 2 more construction lines. First of which I'll just go from the center up to somewhere above there. Doesn't really matter how far because it's only a reference line. And the next one we want to draw from that coincident point back down to the center point. Just turn that off. Alright, so now we'll set some dimensions, and we'll set the dimension between that construction line and our new reference construction line, and that's going to be equal to our pressure angle, which, as you saw earlier in the video, is 20 degrees, which you can see there. And then what we want to do is set another dimension from the line that goes from the coincident point back to the center, to the center line. And this one is a bit trickier. It's going to be 360 divided by, and you want to put this bit in brackets, equivalent teeth 1 multiplied by 4, close bracket. Okay, so that's got all that set. Now what we want to do is mirror this arc. Oops, get rid of the dimension tool. So we'll select the arc and go to mirror, and our mirror line is just going to be the center line. And hit OK, and what you can see is we're actually creating the cutout for the gap between the teeth, so those curves will actually end up creating the teeth themselves after we pattern everything. But before we get to that point, we need to create one more arc. This time it's going to be a 3-point arc, and we need to go from the center point out to just anywhere along that arc, as long as it's outside of those circles. And that's gone the wrong way. Why did it do that? Let's try that again. I think I might have selected 3-point arc instead of center point. Yes, that's better. So you end up with an arc between the two arcs. And deselect our tool, and we want to set a dimension between that new outer arc and the outside circle, and I'm just going to set it at 0.5. The actual value of that dimension doesn't matter, as long as you have just a little extension around the outside of the circle, just to ensure that when we do the loft it goes all the way through the body. So now that we've got that, we can just tidy things up, trim off the ends of those arcs. Why do we just get a warning? Constraints, all dimensions were removed. Really? I'm not sure which ones it thinks were removed. Let me just undo that for a second. Oh, there's another constraint on there. How bizarre. Oh well, doesn't matter. They are actually the same, are they not? Yeah. Alright. So at this point we can stop the sketch and we'll unhide our body so we can see what we're doing. And what we want to do is create a loft, and I want to select those 3 new bits as a profile, and we'll rotate that up a bit, and I'm going to select center point as profile 2, and as you can see it automatically selects cut, which is what we want, and it cuts out a nice hole for our teeth. So the next bit we want to do, and just make it a bit easier to see, hide the sketch, select those faces, and we go to create pattern, circular pattern. So we've got our objects selected and our axis. We can just use the center axis. I'm not sure if this is going to work. Try equivalent teeth 1. Doesn't appear to want to accept that. So we know how many teeth we want for the gear anyway, so we'll just type in 20. I don't know why it won't accept equivalent teeth 1 anymore. It used to accept it. In previous occasions when I've created these gears, it's accepted equivalent teeth as a quantity. For some reason it doesn't seem to now, but since we know the value of that, we can type it in manually, and as you can see, it's created a beveled gear. So that's pretty much it. As I explained earlier in the video, from this point, to create your second gear, basically go back to your front plane and create a line horizontally across that way, a construction line, and then another one through that line, and then set your dimensions as pitch diameter 2 and pitch radius 2, and then do your lines joining the top and bottom and be cone radius to, back cone radius to, and so forth. Basically repeating all the steps that I just did there, but at 90 degrees and with 2 instead of 1. And that's pretty much it. It'll actually create the second gear in the correct position to mesh with the first gear, so it'll be in the right position, but generally the teeth won't be meshed when you actually create it. You'll find that the teeth kind of sit in line with each other, but because it's in the correct position, all you need to do is rotate it, like rotate one of the gears about 5 or 10 degrees, and they will be in the correct position. So that's pretty much it. I hope you've enjoyed this tutorial. If you do, and you want to see more, hit the subscribe button and a little bell to be notified of when cool new things are uploaded, as our great 3D printing nerd friend Joel says. And as some of you may be aware, I've been going through some health issues for the past couple of years. I haven't been able to work and my funds are quite dry. So if you do enjoy what you see and wish to support me, because I still have more problems to deal with yet, there's a couple of links below in the description where you can donate. You can either buy me a coffee or send me a donation through PayPal. And yeah, feel free to leave a comment, ask any questions. I'll be uploading a sort of somewhat written step-by-step tutorial and probably a few diagrams to my Facebook page, which I'll also leave a link to below. So yeah, you can either comment on video or comment over on my Facebook page, or you can hit me up on Twitter. It's at @TheRealWellbot. And yeah, I'll see you next time. Thanks for joining. See ya.